Let's look at a simple example. Let's say we have two random variables x and y, and the joint distribution are given at 0, 0, 0, 1, 1, 0, and 1, 1. So this is a distribution. Let me try to plot this here. Let's say this is x-axis, this is y-axis, and this is the joint PMF. At 0, 0, you have 0.2, so this is 0.2, okay. At 0, 1, so x is 0, y is 1. This here is 0.4. At 1, 0, this is 0.1, and 1, 1, this is 0.3. So this is my PMF, the joint PMF. Okay. Now, I would like to find the marginal distributions first. To compute the marginal distribution of x for a fixed x value, for instance, for x equals 0, so these two are the outcomes which have x as 0. So I need to add them up, 0.2 plus 0.4. So that gives me 0.6. So this plus this. And these two are the outcomes where x equals 1. X equals 1 here, x equals 1 here. So I add them up, 0.1, 0.3, get 0.4. Okay, so this is the marginal distribution of x. How about the marginal distribution of y? Similarly, for y equals 0, so y equals 0 here and y equals 0 here, I need to add these two up. So 0.1, 0.2, you get 0.3. And for y equals 1, these two are the possible outcomes, therefore 0.7. Okay, so you see these two distributions tell us that the joint distribution, ij, is not equal to the product of the marginal distributions. Therefore, these two random variables are not independent. We can say it from these marginal distributions. So they are dependent. X and y are dependent. Let's look at the moments. I have the distributions here. So x is with probability 0.6, it is 0. And with probability 0.4, it is 1. So the mean is 0.4. You see, essentially, this is a Bernoulli random variable with parameter 0.4. So its expected value is 0.4. Its also second moment is 0.4. And from this, I can compute the variance as the second moment minus the square of the first moment, which makes 0.24. Similarly with y is also a Bernoulli random variable with parameter 0.7. So its mean value is 0.7, second moment is 0.7. And using these two, I can compute the variance as 0.21. And I can compute using the joint distribution here, I can compute the correlation. You see, in this outcome, this one and this one, the product of x and y is 0. 0 times 0, 0 times 1, 0, 1 times 0, all 0. So 0 times 0.2, 0.4, 0.1. So this term is going to be 0. And their product is 1 here times 0.3 probability. So 0.3 is the correlation between the two. How about the covariance? The covariance is equal to the correlation minus the product of the means. And the correlation is 0.3 and the means are 0.4 and 0.7. So their difference is 0.02, which is the covariance between the two. And if you divide this by the standard deviations, or rather the square roots of the variances, you get the correlation coefficient between the two as around 0.089. Now, as an exercise, recall this 0.2, 0.4, 0.1, 0.3. If you change them into 0.28, 0.12, 0.42, 0.18, repeat this procedure And in this case, you will see that X and Y are independent. So I recommend you do this yourself. Compute the marginals. You will see that the joint distribution is equal to the product of the marginals. And compute the moments, compute the covariance. You will see that the covariance as well as the correlation coefficient will turn out to be 0.